Hello students, in today's class let us continue with the topic derivatives. So before we get into the new topic, I wish to give you a quick recap of what we have learnt in yesterday's class. We have seen what is meant by derivative. If f is a real valued function, then the derivative of f at a is defined as limit h tends to 0 f of a plus h minus f of a divided by h, provided all the limit exists. And the derivative of the function is denoted by f dash of a, right? This quantifies the change in f of x at a with respect to x. Then we have seen what is meant by first principle of derivative. This is called as first principle of derivative. This is in particular at the point a we have defined. Here in general f dash of x is limit h tends to 0 f of x plus h minus f of x divided by h. And also we have seen different notations for the derivative of a function f dash of x, which can also be written as d by dx of f of x, which means a derivative of f of x with respect to x, and it can also be written as dy by dx, and we have seen certain other notations as well. And based on this we have seen how to solve some basic problems, how to find the derivative of the given function. So in today's class we are going to see algebra of derivatives. In today's class we are going to see algebra of derivatives of functions. This is like extension of what we have seen in limits. The same thing we are going to see for derivatives. What happens if the derivative, what happens to the derivative of sum of two functions, difference, product and the quotient? If we have sum of two functions, then the derivatives can be written like this. D by dx of f of x plus g of x is nothing but d by dx of f of x plus d by dx of g of x. We can find the derivative of f of x separately, g of x separately, and then we can add, which is same as adding two functions and finding its derivative, right? Similarly with the difference of two functions, d by dx of f of x minus g of x is d by dx of f of x minus d by dx of g of x, right? Next comes product. Here alone you have to be very careful. This is not like as we have done in our limit. Limit we have just multiplied the two functions, but here we have a little change. This is called as product rule. What is product rule? D by dx of f of x into g of x is nothing but d by dx of f of x into g of x, which means first we are keeping g of x as a constant and we are finding the derivative only for f of x, plus next we are going to keep f of x as constant and we are going to find the derivative for g of x, right? D by dx of f of x into g of x is d by dx of f of x into g of x plus f of x into d by dx of g of x. What are we doing here? First we are keeping g of x as a constant and we are finding the derivative for the function f of x, plus we are keeping f of x as constant and we are finding the derivative for g of x. This can also be written as uv the whole dash, because this seems to be tedious, right? So how to written it in a short form? If we take f of x as u and g of x as v, uv the whole dash. Dash also denotes the derivative. In yesterday's class we have seen the various notations, right? So there we have seen if we write whole dash, it also denotes its derivative. So uv the whole dash is equals to u dash v plus uv dash. First we are keeping v as such and we are differentiating u, plus we are keeping u as such and we are differentiating v. This is called as product rule, right? Next we are going to see quotient rule. What is quotient rule? D by dx of f of x is equals to d by dx of f of x into g of x. The same way as we have done in product rule. First we are going to keep the denominator as a constant and we are finding the derivative of the numerator. Here it is minus. In the product rule it is plus. In the quotient rule it is minus. Minus f of x into d by dx of g of x, the whole divided by g of x the whole square, the denominator the whole square, right? This can also be written in short form as u by v the whole dash is equals to u dash v minus uv dash divided by v square. You have to remember these two rules, product rule and the quotient rule. What is product rule? uv the whole dash is u dash v plus uv dash. Quotient rule is u by v the whole dash is equals to u dash v minus uv dash divided by v square, right? This product rule is also known as Leibniz rule. This product rule is also known as Leibniz rule. Next, what we are going to see is two important theorems. First one is d by dx of x power n is n into x power n minus 1. As we have seen few important results in limits topic, this also you have to remember. This is like a formula, right? d by dx of x power n. What does it mean? We are differentiating a function x power n with respect to x. If we are going to differentiate a function with respect to that particular variable, if we have in the form of x power n, then which is nothing but n into x power n minus 1. So d by dx of x power n is n into x power n minus 1. Next theorem is, this is like a derivative of a polynomial as we have seen in limits. A derivative of a polynomial an x power n plus an minus 1 x power n minus 1 plus etc. an x plus a naught. So what will happen to this? d by dx of f of x is equal to, here we are going to apply repeatedly the result of d by dx of x power n, d by dx of x power n. So what will happen here? X power n if we differentiate, and again we are going to apply the algebra of derivatives. Sum of functions we have, right? So we can find the derivative of this plus derivative of this, like that we can do. So if we apply repeatedly the algebra of derivatives and the previous result, we will obtain this. What it is? an into x power n, if we differentiate we will get n into x power n minus 1. Then an minus 1 is a constant. X power n minus 1 if we differentiate we will get n minus 1 into x power n minus 2 plus etc. a1 into x if we differentiate, x means power 1, right? So 1 into x power 1 minus 1, x power 0, anything power 0 is 1. So we will end up with only a1 plus a naught. A naught if we differentiate with respect to x, what will happen? Which means a naught means x power 0. So 0 into x power. So 0 into anything is going to be 0 only. So this entire term will be equal to 0. Right? So the differential of a polynomial f of x equal to an x power n plus an minus 1 x power n minus 1 plus etc. a naught is nothing but n into an x power n minus 1 plus n minus 1 into an minus 1 into x power n minus 2 plus etc. 2a2x plus a1. So from this what we infer, if we differentiate constant with respect to some other variable, it is going to be 0. Differentiation of a constant is going to be 0. And if you differentiate a variable with respect to the same variable, it is going to be 1. Right? d by dx of x is going to be 1. If we are going to differentiate the variable with respect to the same variable, it is going to be 1. And d by dx of any constant is going to be 0. Right? You have to remember this. Right? So based on all these results, now let us get into problems. Now let us see how to solve this problem. Compute the derivative of 6x power 100 minus x power 55 plus x. This is the direct application of the previous theorem. What we have seen, d by dx of x power n is equal to n into x power n minus 1. We are going to apply this result and the application of algebra of derivatives, right? So what will happen now? We need to find d by dx of our function 6x power 100 minus x power 55 plus x, right, which is equals to d by dx of 6x power 100 minus d by dx of x power 55 plus d by dx of x. So which is nothing but 6 into, this is like x power n. X power n is n into x power n minus 1. So n is 100. 100 into x power 100 minus 1, which is going to be 99, minus similarly 55 into x power 54 plus, I told you d by dx of x is 1. So which is equal to 600 x power 6 into 100 minus 55x power 54 plus 1 is the derivative of the given function. Right? Hope you understood. Similarly, wherever the question is given, you have to apply the results and the theorems which we have learnt. Now let us see the another example. They asked you to find the derivative of f of x, which is equal to 1 plus x square plus etc. x power 50 at x equal to 1. So first let us find the general derivative f dash of x. It can be written as f dash of x, or you can also write it as d by dx of f of x. Right? It's your wish. You can write it in any way. Which is equal to what? We are going to apply this result. We know the derivative of the constant is 0, right? We are going to apply the derivative for this polynomial. First we have to differentiate 1 with respect to x. If we differentiate 1 with respect to x, it is going to be 0, plus if we differentiate x with respect to x, it is going to be 1, plus x square, it is going to be 2 into x power n minus 1. So it is going to be 2x, plus x cube means it will be 3 into x square, plus etc. plus 50 into x power 49. Hope you understood. We have applied this result, n into x power n minus 1. So which is nothing but 1 plus 2x plus 3x square, 3x square plus etc. plus 50x power 49. This is what f dash of x. But they asked you to find the derivative at x equals to 1. Therefore, at x equal to 1, f dash of 1, which is going to be in the place of x, we need to replace 1. So 2 into 1 plus 3 into 1 square plus etc. plus 50 into 1 power 49. So which is going to be 1 plus 2 plus 3 plus etc. plus 50. So sum of first n natural numbers. What is the formula? N into n plus 1 by 2. So 50 into 51 divided by 2. What is the formula? N into n plus 1 by 2. Alright. So which is nothing but 1275. Right. 225s are 25 into 51 is 1275. Hope you got it. This is again the mere application of the theorem what we have learnt. Right. Now let us see how can we find the derivative of this function f of x, which is x plus 1 by x. This cannot be directly find because this is of the form u by v. Numerator f of x by g of x. Numerator we have one function and denominator we have another function. So we have to go with quotient rule. Right. So d by dx of f of x or f dash of x, which is equals to d by dx of x plus 1 divided by x. We are going to go with u by v rule, quotient rule. What is u by v rule? What is u by v rule? U dash v minus u v dash divided by v square. Right? U dash v minus u v dash divided by v square. Here u is x plus 1 and v is x. Right? So first we have to differentiate u dash. U dash means we have to differentiate x plus 1 with respect to x. X plus 1 with respect to x, if we differentiate, x if we differentiate we will get 1 and 1 if we differentiate we will get 0. So u dash is going to be 1 and v dash is going to be x. If we differentiate with respect to x, it is going to be 1. Right? Therefore, u dash is 1, v dash is 1. Now we are going to apply in this formula. U dash v. What is u dash? 1 into v. V is x minus u. U is x plus 1 into v dash. V dash is also 1 divided by v square. V is nothing but x, so x square. So x into 1 is x, plus into minus is minus, 1 into x is going to be x, again plus into minus is minus, 1 into 1 is 1 divided by x square. So plus x minus x will get cancelled So the answer is minus 1 by x square. So hope you understood where you have to use the product rule and the quotient rule. When you have product of two functions, you have to go with product rule. When you have fraction of two functions, you have to go with quotient rule. First, you have to identify which is your u, which is your v. Find u dash and v dash separately. Keep everything aside and then substitute in the formula. That's it. Okay, this is x squared. Hope you got it. Let us move on to the next problem. Now let us see how to find the derivative of f of x, which is equal to sin x, right? It's a trigonometric function. We have not learned any theorem so far. So we are going to go with the normal definition of a derivative. What is the d by dx of f of x, which is equals to limit h tends to 0 f of x plus h minus f of x divided by h. This is what the definition we have learnt. So limit h tends to 0 f of x plus h. F of x is sin x. So f of x plus h is going to be sin x plus h minus sin x divided by h. Now numerator, we are going to apply sin A minus sin B formula. What is sin A minus sin B formula? Hope you remember. I told you a method to remember. S plus S, S minus S. C plus C, C minus C. SC, CS, CC, SS minus, right? So when it is S minus S, it is going to be CS. So limit h tends to 0 2 times. Hope you remember this. S plus S, S minus S. Here it will become SC, CS. So we need S minus S, it is CS. Before we will put 2. Right? So it is A plus B by 2, A minus B by 2. If it is sin A plus sin B, we will write sin 2 sin A plus B by 2 cos A minus B by 2. The same way here, 2 cos A plus B by 2. A is x plus h, B is x divided by 2 into sin A minus B by 2. So x plus h minus x divided by 2, the whole divided by h. So which is nothing but limit h tends to 0, 2 into cos, what we have, x plus x is 2x plus h divided by 2, right? Into plus x minus x will get cancelled, sin h by 2, the whole divided by h, right? So which is equals to limit h tends to 0. This we can write it as 2. See, we can separate the denominator, right? So if we write this 2 for this 2x, 2 will get cancelled. We will get x plus h by 2, right? X plus h by 2. This 2 is for both the terms. So for the first term, if we write 2 will get cancelled. We will get x. For the other term, it is x h by 2 into sin h by 2 divided by h by 2. I can write this 2 to the denominator of h, right? Why I have written like this? Because we know a result, limit x tends to 0, sin x by x is 1. So in order to use that, we have rewritten like this, right? Now this can be written as limit h tends to 0, cos x plus h by 2, product of limits, limit h tends to 0, sin h by 2 by h by 2. We know when h tends to 0, h by 2 also will tend to 0. Therefore, limit of this term is going to become 1. This is going to be 1. Now, what will happen to this? When h tends to 0, it is going to be cos x, right? So, the answer is I am writing here, limit h tends to 0, cos x plus h by 2. If we put h is equal to 0, it is going to be cos x into 1. So, the answer is cos x. So, if we differentiate sin x, we are getting cos x, right? So, this is like a formula you have to remember. When we differentiate sin x, it is cos x. So, d by dx of sin x is cos x, right? You have to remember d by dx of sin x is equals to cos x. As we have learnt a formula for d by dx of x power n, What is d by dx of x power n? N into x power n minus 1. The same way d by dx of sin x is cos x. So in the further exercise problems where if we come across d by dx of sin x, we can directly write cos x. We don't want to undergo all these procedure, right? You have to remember this. So differentiation of sin x with respect to x is nothing but cos x. Hope you understood how we got this. This is with the general definition of a derivative, right? Now similarly, let us find the derivative of tan x the same way. Limit h tends to 0, f of x plus h minus f of x divided by h. So tan x plus h minus tan x divided by h. Tan x can be written as sin by cos. So sin x plus h divided by cos x plus h minus sin x by cos x. We have h, right? Now we are going to take LCM. So denominator we will be having cos h plus x plus h into cos x. Numerator we have to cross multiply since we have taken LCM. Now we are going to apply sin a plus b formula because this is of the form sin a cos b minus cos a sin b. So which is nothing but sin a plus b. A is x plus h, b is x, right, divided by the denominator we have. Now plus x minus x will get cancelled. So we got sin h by h into, again we have separated since we know limit h tends to 0, sin h by h is 1. So the remaining terms 1 by cos x plus h into cos x, right. So this term is going to be 1 and this is when h tends to 0, it is going to be cos x. Cos x into cos x is cos squared x. So 1 by cos squared x is nothing but secant square x. So this is also a known result. You have to remember differentiation of tan x is secant square x. Differentiation of tan x is secant square x. So far we have learnt all these results where you have to by heart. D by dx of x power n is n into x power n minus 1. D by dx of x, which means if we want to differentiate a particular variable with respect to the same variable, it is going to be 1. If you are going to differentiate any constant with respect to some variable, it is going to be 0. If we differentiate a sin x with respect to x, it is going to be cos x. If you are going to differentiate tan x with respect to x, it is going to be secant square x. You have to by heart all these results, right? Now using all these things, let us see how to solve few problems now. Now let us see how to solve these problems. Till 4th question we have done in our last class. Now look into the 5th question. For the function f of x equal to x power 100 divided by 100 plus x power 99 divided by 99 plus etc. x square by 2 plus x plus 1. How to find the derivative? And for this function they asked you to prove that f dash of 1 is equals to 100 into f dash of 0. This is similar to the example which we have done. Second example which we have done. Hope you remember. So there we don't have any denominators. Here we have denominator as a constant. Doesn't matter. So when you are going to differentiate x power 100, you keep 1 by 100 aside. So this can be written as 1 by 100 into d by dx of x power 100 plus 1 by 99 into d by dx of x power 99, etc. Here also 1 by 2 into d by dx of x square plus d by dx of x plus d by dx of 1. First write like this and then proceed your differentiation. So when you differentiate x power 100, what you will get? What will be the derivative? 100 into x power 99. So that 100 and this 100 will get cancelled. Likewise for every term. When you differentiate ax, you will get 1. When you differentiate 1, you will get 0. So after finding the derivative f dash of x, you find what is f dash of 1 and what is f dash of 0. That is, in the place of x you put 1 and in the place of x you put 0. Obtain the values and then check whether f dash of 1 is equal to 100 into f dash of 0 or not. Okay. Hope you can do this problem. If you have any doubts, you can check with the example 2 what we have done. Right? Let us move on to the next question. Find the derivative of x power n plus a into x power n minus 1 etc. for some fixed real number. This is exactly same as the previous problem. Instead of giving you constants, they have given you a numerical constant. They have given you a a as the constant, fixed constant, right? So instead of numbers you will have a, that's it. So it is enough if you find the derivative. So what is the derivative of this? N into x power n minus 1 plus a into n minus 1 into x power n minus 2 likewise you will get, right? Now let us see how to solve the seventh question. For some constants a and b, find the derivative of x minus a into x minus b. This can be solved in two ways. I told you whenever you have product of two functions, you can go with product rule. You can go with product rule, or else you can, in the first step itself, you can multiply and make it as a polynomial, and then you can find the derivative as we have done for our earlier question, fifth question, right? You can multiply term by term, x into x, x into b, a into x, a into b. You will get a polynomial. Then you can find the derivative of that, or else you can go with product rule. Now I'll show you how to solve this problem using product rule. Now let us see how to find the derivative of this problem using product rule. So let f of x, if we take f of x is equal to x minus a into x minus b. We are going to assume this function as u and this as v. So u is equal to x minus a, v equal to x minus b. Therefore what will be u dash? U dash is differentiation of this. If we differentiate x with respect to x, it is going to be 1. If we differentiate minus a with respect to x, it is going to be 0. So u dash is 1. Similarly, v dash is also 1. Now what is product rule? uv the whole dash is equals to uv dash plus u dash v, right? Now we are going to substitute in this. Therefore f dash of x is equals to u v dash. What is u? X minus a into v dash is 1 plus u dash is 1, v is x minus b. Now let us expand. X minus a into 1 is x minus a plus x minus b into 1 is x minus b. So x plus x is 2x minus a minus b is the answer. So you can solve this problem using product rule like this, or else you can multiply the, let me show you how to solve the problem without using product rule. Initial step itself you can multiply and make it as a polynomial. X into x is going to be x square minus bx minus ax, minus into minus it is going to be plus ab. Now let us find f dash of x. F dash of x is going to be, now we can apply algebra of the derivatives here because it is sum and difference of the terms. So first we will differentiate x square. If we differentiate x square with respect to x, it is going to be 2x because n into x power n minus 1 formula, minus bx. B is a constant, so we can take b out. Differentiation of x is 1 minus a into differentiation of x is 1 with respect to x plus ab is a constant. So if you differentiate with respect to x, it is going to be 0. So which is equals to 2x minus b minus a, right? We got the same answer. So it's up to you whatever method you are going to adopt, but it is advisable to go with the product rule because every time we cannot multiply and make it as a polynomial, and we cannot proceed with this. If you understand what is product rule and where you have to apply, it will be useful in the forthcoming problems, right? Hope you understood. Let us move on to the next question. Now the next question is f of x is ax square plus b the whole square. This problem also can be solved in two ways. One is using d by dx of x power n formula. What is d by dx of x power n? N into x power n minus 1, right? Now we have to consider this entire term as our x. Entire term as our x. So x power n, if we differentiate, what will happen? N into x power n minus 1. So 2 into a x square plus b is our x whole power 2 minus 1, right? Normally if it is going to be simply x, we will stop with this, but here our x is not simply x. Here the value of x is ax square plus b. So what you have to do is you have to undergo one more step, like differentiating this d by dx of ax square plus b. Hope you understood. I repeat what I have done here. Our formula is d by dx of x power n is n into x power n minus 1. When you are differentiating the function x with respect to x, right? Simply if you have the same variable, if you have, then it is simply n into x power n minus 1. But here we are going to differentiate with respect to x, but it is a complex function. It is not simply x. It is ax square plus b. So first step, we have to apply this result. Then you have to multiply it by the differentiation of that complex function d by dx of ax square plus b. Right? This is the procedure to perform. So which is equals to 2 into ax square plus b. 2 minus 1 is 1. The power is going to be 1 into. Now we can differentiate this. This is just a sum of two functions. So you can do the differentiation. How you will do the differentiation? Ax square. So a is a constant. X square, if we differentiate with respect to x, again the same formula, n into x power n minus 1. So it is going to be 2x, right? Plus d by dx of b. B is a constant. So if we differentiate that, it is going to be 0, right? X square, if we differentiate with respect to x, it is going to be 2x. So which is equals to 2 into ax square plus b into 2ax. This term is going to become 0. So this can also be written as 2 into 2 is 4ax into ax square plus b is the answer, right? The same problem can be solved in the another way. Initially, you can make it as a polynomial by expanding using a plus b the whole square identity. Now let me show you how to do that. So f of x, expand it using a plus b the whole square identity, a square. So it is going to be a square x power 4 plus b square plus 2ab, right? I have expanded using a plus b the whole square identity, a square plus b square plus 2ab. Now you find f dash of x. Now f dash of x is a square into x power 4, differentiation is x power n formula, n into x power n minus 1. So 4 into x cube plus b square is constant. So if you differentiate, it will become 0 plus here 2ab is constant, 2ab into x square, if we differentiate, it is going to be 2x. Kindly make out the difference between this constant and here. This is a constant term. Here 2ab is the coefficient of a variable, right? Coefficient of a variable you have to write as such and differentiate the variable alone. But when you have a constant term, when you differentiate with respect to the variable, it will become 0 because constant term can be accompanied by the variable power 0. So when you apply x power n formula there, it will become n into x power, so 0 into, so the entire term will become 0. Don't get confused with this constant and this constant. This is called the coefficient, this is called the constant term. The coefficient you have to write as such and then you have to differentiate the variable, right? Now this is nothing but 4a square x cube plus 2 2's are 4abx, right? This is same as this. If we take 4ax as common, what we will get here? Ax square plus b, right? We have taken 4ax as common. So we ended up with the same answer. So it's up to you how are you visualizing the question and how are you going to undergo the differentiation, right? Hope you understand both the methods, so you can adopt any method. And again, every time when you are expanding and differentiating is not advisable. It is, you should know how to perform it using x power n formula as we have done product rule in the previous question, right? Now let us see how to solve the 8th question. F of x is x power n minus a power n divided by x minus a. On looking at the question, immediately you can identify what rule we are going to use. We are going to use quotient rule. What is quotient rule? U by v the whole dash is equals to vu dash minus uv dash divided by v square. Remember, when we do the product rule, we will start with uv dash, right? When it is quotient rule, you have to start with v. U dash, u first you have to differentiate. Since we have negative sign in between, if you change the order, you will end up with the wrong answer. Product rule, we have sum of two terms, so it doesn't matter in whichever order you perform. But when it comes to quotient rule, first you have to differentiate u and then only you have to differentiate v. Numerator is u, denominator is v, right? So let us identify what is our u and v. U is x power n minus a power n. V is x minus a, right? So what is going to be u dash? U dash is x power n. If we differentiate, it is going to be n into x power n minus 1. A is constant, so if we differentiate, it will become 0. Similarly, v dash is going to be x. If we differentiate, it is going to be 1. A, if we differentiate, it is going to be 0. So we have identified what is u, what is v, what is u dash, and what is v dash. Now we are going to substitute in the formula. Therefore, f dash of x is equals to v u dash. V is x minus a into u dash is n into x power n minus 1 minus u into x power n minus a power n. V dash is 1. The whole divided by v square. V square is x minus a the whole square. Right? Now we can expand the numerator by multiplying. So if we multiply first term, we will get n into x power, already n minus 1, here power is 1. So if we add the powers, plus 1 minus 1 will get cancelled, we will get x power n, right? Minus a n x power n minus 1 minus x power n into 1 is x power n, minus into minus it is going to be plus a power n, right? Divided by x minus a the whole square. That's all. If we want, we can take common from x power n here. Again, it is going to be n minus 1 into x power n minus a n into x power n minus 1 plus a power n divided by x minus a the whole square. It doesn't going to make much difference, so you can leave the answer as such also. It doesn't matter, right? Hope you understood how we have used the quotient rule here, right? In the same way, you can solve this problem x minus a divided by x minus v as we have solved this by u by v rule, right? And you can do all the problems in the 9th question by your own. First question, you can differentiate 2x separately. This is sum of two functions, so no problem. Here you can go with product of two, product rule. You can take u as 5x cube plus 3x minus 1 and v as x minus 1. You can go with uv rule. Here also you can go with uv rule, u as x power minus 3, v as 5 plus 3x. Don't get panic on looking at the negative power of x. Anyhow, the value of n is going to be minus 3. So when you apply x power n derivative formula, it is going to be n into x power n minus 1. So minus 3 into x power minus 3 minus 1. So x power minus 4. So even the derivative will have a negative powers. It doesn't matter. Okay, because that theorem is true for any value for n, right? So you can apply, it is true for any value of n, so you can apply it for negative powers as well, right? True for all powers of n. See, it is given in the question. The above theorem is true for all powers of x, that is n can be any real number, but we will not prove it here, right? But it is true for any value of n, so you can use that result and solve the problem. So you can go with uv rule again. The same way here also uv rule, here also uv rule, right? And inside also we have negative powers. Don't worry, go with x power n formula. How will you solve this question? You can adopt u by v rule for this separately and u by v rule for this separately, and then you can subtract. So d by dx of, again here we are applying the algebra of derivatives only. This is actually sum of two functions. So you can differentiate this function minus d by dx of this function. But how will you differentiate this function? You have to go with u by v rule. This also you have to go with u by v rule, right? So hope you can do all these problems by your own. And also the 10th question, find the derivative of cos x from first principle. What is meant by first principle? Using the limit formula. Limit h tends to 0, f of x plus h minus f of x divided by h. Using that we have found what is the derivative of sin x? Hope you remember. The same way you have to do it for cos x. Okay, when you differentiate cos x, you will end up answer with minus sin x. So you have to remember differentiation of cos x is minus sin x. So using first principle, you have to solve this problem, right? So with this, let us wind up today's class. Do these questions as a homework and post it in the group without fail. And if you have any doubts, you can ask me. Thank you, students.